Hello Year 8. Today we have our second lesson on volume. Last lesson we were looking at cubes and rectangular prisms, finding volumes and converting them into capacities. Today we want to focus on some other types of prisms and also cylinders. So first of all, it's important to note that a cylinder is not a prism. It has identical ends, but because the sides between the ends are not flat, it is not considered to be a prism because prisms are meant to have flat faces. However, we can treat it like a cylinder when finding the volume because it has a constant cross section. So to find the volume of any prism, we can use this formula here. V is equal to A times H. Now the A is the area of whatever the cross-section shape is of your prism. So this one that's shown in the diagram is a triangle. So you would find the area of a triangle. But it could be a trapezium, it could be a parallelogram, it could be many different types of shapes there to find the area. And then you just times it by the height of the prism. Now a cylinder, like we said, is not a prism, but the area of a circle, which is the one at the end, is pi r squared, and we just times that by the height. So it really is V equals AH as well, where the area is pi r squared. Okay, so examples. State whether the following are prisms or not. Okay, so something is a prism if it has the same size shape at each end and the area is consistent the whole way through the shape. So if you were to slice it up, you would have the same size face the whole way through the shape. So this first one here, it has a rectangle on either ends and it's the same the whole way through the shape. So yes, that one is a prism. Part B has a triangle on the front and the back. And if I was to cut it up, all those little triangles would be the same size, so it is also a prism. Part C, it does not have a shape at the front and the back. It is actually coming up to an apex. That is called a pyramid, so it is not a prism. And D, that is also not a prism, that is a cone. Again, the shape is changing as you go from one end to the other. Okay, question 2. Find the volume of the following shapes and convert your answers into liters again. So the first one is a cylinder. The formula for the volume of a cylinder is pi r squared h. Substituting into that, the radius is 2, so pi times 2 squared times the height, which is 4. So in the calculator, pi times 2 squared times 4 is 50.27. And that is centimeters cubed because it's volume. Remember that centimeters cubed are exactly the same as milliliters. And to convert milliliters into liters, I just divide it by 1,000. So 0.05, if I do 2 decimal places, liters. Let's do part B. It is a triangular prism. So I'm going to need to use the formula V is equal to AH. Now, because this is a prism, first of all, I need to find the A though. The A is the area of the shape that is at the front and the back of the prism. So in this case, it's a triangle. So over here on the side, I want to find the area of a triangle using the formula A equals half base times height. So for mine to substitute in, A is equal to half times the base, which is 4.5, times the height, which is 5. Timesing those together, we get 11.25. that would be centimeters squared because it's an area. Now that I found the area, I can find the volume. The A is what I just found, which was the 11.25, and the height is the side coming back from the area, which is that 8 centimeters. Okay, so times that by 8, and I get 90 centimeters cubed for the volume. Centimeters cubed are the same as milliliters, and to change milliliters into liters, I divide it by 1,000, which is 0.09 liters. Part C, to find the volume of that prism, we need V is equal to AH. Now, to help us out, this one actually gives us the area. I don't need to calculate it. It tells me that the area is 15 centimeters squared. So I can put that straight in for the A, and the H is the height going up, which is the 8. And when I times those together, 15 times 8 is 120 centimeters cubed. Centimeters cubed are exactly the same as milliliters, and we divide the milliliters by 1,000 to turn that into liters, which is 0.12 liters. Part D, we have a trapezoidal prism, which means it has a trapezium on the front. So first of all, I'm going to start by finding the area of that trapezium. The formula for a trapezium is h over 2 bracket a plus b. The height is this perpendicular one here, that's the 0.6 over 2. The a and the b are the two parallel ones, which would be those two there, the 0.8 and the 1.5. We calculate that. So we have 0.6 over 2 times 0.8 plus 1.5. So that's 0.69 meters squared. Then I can find the volume of that prism using the V equals AH. The area is the 0.69 that I just found. The H is the height going back, which is this 3 meters here. So 0.69 times 3 is 2.07 meters cubed. Now, I haven't had a meters cubed one yet. Meters cubed are the same as kiloliters. Kiloliters are 1,000 liters, so we times that by 1,000 to get 2,070 liters. All right, we have a couple of harder ones here at the end. We want to find the volume of some composite shapes. So I have two shapes to add together here. For the first one, I have half of a cylinder, so that's half of pi r squared h, because pi r squared h is the volume of a cylinder. Plus, I have a rectangular prism, which has the formula LBH. Okay, so let's substitute into those formulas. Half of pi r squared h. The radius of my cylinder would come from this 20. The 20 would be the diameter, so the radius would be equal to 10. So pi times 10 squared times by the height of my cylinder, which would be that height there, the 50. Plus, okay, that's the half cylinder done. Plus, we want the rectangular prism, which is the 20, the 50, and the 15 all multiplied together. 20 times 50 times 15. And type it all in. Half times pi times 10 squared times 50 plus 20 times 50 times 15. 22853 0.98, and that is in meters cubed. I'm not asked to change these ones into capacity, so that's the end for this question. In part B, what I'm going to do is I'm going to slice this down here so that I have two rectangular prisms next to each other. So the volume is going to be LBH for the first one, which I'll call this one here, plus I'll have LBH for the second rectangular prism as well. So substituting in my numbers for the first one, the little one, the length, the breadth and the height would be 8 times 7 times the 42 going back. 8 times 7 times 42. Plus, now the big one, the height of that is 18. The breadth here is 9 and the 42. So 18 times 9 times 42. And calculate. 8 times 7 times 42 plus 18 times 9 times 42. 9156. And centimeters cubed for volume. And we're done.